Hello friends and welcome to the lecture on water conservation, rainwater harvesting and watershed management. Now an overview about the objectives which we are going to discuss. Firstly, to know about water conservation and its importance. Secondly, to understand how rainwater harvesting is important for water conservation. And lastly, I'll discuss about watershed and its management practices. Although water is very abundant on this earth, yet it is very precious. Out of the total water reserves of the world, about 97% is salty water and only 3% is fresh water. Even this small fraction of fresh water is not available to us, as much of it is locked up in polar ice caps and just 0.003% is readily available to us in the form of groundwater and surface water. Most of the civilizations have grown and flourished on the banks of the rivers, but unfortunately, growth in turn has been responsible for pollution of the rivers. As a result, billions of people do not even have access to safe drinking water. It's estimated that by 2024, two-thirds of world population would be suffering from acute water shortage. Water scarcity has emerged as a prominent issue for communities across the countries. In fact, one of the most critical natural resource issues facing communities today is managing the supply and availability of water. As the supply of available water has decreased, demand for water has grown. The rise in water demand combined with the decline in water supplies can have dire consequences for communities. Current water consumption practices are unsustainable and must be altered. To meet the demand for water supply in the future, communities will need to work to conserve and relocate existing water resources. Water conservation is defined as any action that reduces the amount of water withdrawn from water supply sources, reduces consumptive use, reduces the loss or waste of water, improves the efficiency of water use, increases recycling and reuse of water, or prevents the pollution of water. Water conservation encompasses the policies, strategies, and activities to manage fresh water as a sustainable resource, to protect the water environment, and to meet current and future human demand. Water conservation should be an integral part of long-term resource planning. It might be more appropriate to use the term water demand management. Traditional water supply management seeks to provide all the water the public wants, which in some sections of the country translates to a constant search for untapped resources. What methods conserve water? EPA's basic guidelines suggest metering, water accounting and loss control, pricing and costing, and education or information. EPA's guidelines are not regulations but recommendations that suggest 11 different conservation methods. How appropriate and desirable any given method is must in the end be accepted by the individual community and utility. According to a US Housing and Urban Development document, metered customers use an average of 13 to 45% less water than unmetered customers because they know they must pay for any misuse or negligence. However, some simpler methods which can be used in a country like India are decreasing runoff losses. Huge water loss occurs due to runoff on most of the soils, which can be reduced by allowing most of the water to infiltrate into the soil. Contour cultivation on small furrows and ridges across the slopes trap rainwater and allow more time for infiltration. Terracing constructed on deep soils has large water storage capacity. Conservation bench terracing involves construction of series of benches for catching the runoff water. Water spreading is done by channeling or lagoon leveling. In lagoon leveling, small depressions are dug in areas so that there is temporary storage of water. Chemical wetting agents, surfactants, increase the water intake rates when added to normal irrigated soils. Surface crop residues, tillage, mulch, animal residues, etc. help in reducing runoff by allowing more time for water to penetrate into the land. Chemical conditioners like gypsum when applied to sodic soils improve soil permeability and reduce runoff. Another useful conditioner is HPAN, that is hydrolyzed polyacrylonitrile. Water storage structures like farm ponds, dugouts, etc. built by individual farmers can be useful measures for conserving water through reduction of runoff. Reducing evaporation losses. This is more relevant in humid regions. Horizontal barriers of asphalt placed below the soil surface increase water availability and increase crop yield by 30 to 45%. This is more effective on sandy soils, but less effective on loamy, sandy soils. A copolymer of starch and acrylonitrile called super slurper has been reported to absorb water up to 1400 times its weight. The chemical has been found to be useful for sandy soils. Storing water in soil. Storage of water takes place in soil root zone in humid regions when the soil is wetted to field capacity. By leaving the soil fallow for one season, water can be made available for crop grown in next season. Reducing irrigation losses. Use of lined or covered canals to reduce seepage. Irrigation in early morning or late evening to reduce evaporation losses. Sprinkling irrigation and drip irrigation to conserve water by 30 to 50%. And growing hybrid crops varieties with less water requirement and tolerance to saline water help conserve water. Reuse of water. Treated wastewater can be used for irrigation. Using grey water from washing bath, tubs, etc. for watering gardens, washing cars or paths help in saving fresh water. Preventing wastage of water. This can be done in household, commercial buildings and public places. Closing taps when not in use, repairing any leakage from pipes, using small capacity flush in toilets. Now, rainwater harvesting. There are three important natural sources of water besides abundantly available seawater. The seawater, being saline, cannot be used as such either for industries or for domestic consumption. They are rainwater or snow water, surface water, that is river, lakes, stream, canals, ponds, etc. and groundwater or subsoil water, wells and springs. Rain is the ultimate source of fresh water, with the ground area around houses and buildings being cemented, particularly in cities and towns. Rainwater which runs off from terraces and roofs was draining into low-lying areas and not percolating into the soil. Thereby, precious rainwater is squandered as it is drained into the sea eventually. Rainwater harvesting is a technique of increasing the recharge of groundwater by capturing and storing rainwater. This is done by constructing special water harvesting structures like dug wells, percolation pits, lagoons, check dams, etc. Rainwater, wherever it falls, is captured and prevented from being polluted. Rainwater harvesting is not only providing useful for poor and scanty regions but also for rich ones. Rainwater harvesting has following objectives: to reduce runoff loss, to avoid flooding of roads, to meet the increasing demands of water, to raise the water table by recharging groundwater, to reduce groundwater contamination and to supplement groundwater supplies during lean season. Rainwater harvesting is a system by which rainwater that collects on the roofs and the area around the buildings is directed into open wells through a filter tank or into percolation chamber built specifically for this purpose. Rainwater is collected directly or recharged into the ground to improve groundwater storage. Water that is not extracted from ground during rainy seasons is water saved. Rainwater harvesting is a technology used for collecting and storing rainwater from rooftops, the land, surface or rock catchments using simple techniques such as jars and pots, traced back almost 2000 years in Thailand, as well as more complex techniques such as underground check dams. The history of rainwater harvesting in Asia can be traced back to about 9th or 10th century, and small-scale collection of rainwater from roofs and simple brush dams constructions in the rural areas of South and Southeast Asia. Rooftop catchment rainwater storage tanks can provide good quality water, clean enough for drinking as long as rooftop is clean, impervious and made from non-toxic materials, lead, paints and asbestos. Roofing materials should be avoided. Commonly used systems are constructed of three principal components, namely the catchment area, the collection device and the conveyance system. Firstly, the catchment area, which includes rooftop catchment. Rainwater is collected in simple vessels at the edge of the roof. Variation on this basic approach include collection of rainwater in gutters which drain to collection vessel through downpipes constructed for this purpose. As the rooftop is the main catchment area, the amount and quality of rainwater collected depends on the area and type of roofing material. Land surface catchments. Rainwater harvesting using ground or land surface catchment areas is less complex way of collecting rainwater. It involves improving runoff capacity of the land surface through various techniques including collection of runoff with drain pipes and storage of collecting water. By retaining the flows of small creeks and streams in small storage reservoirs created by low-cost dams, this technology can meet water demands during dry periods. Increasing slope. Steeper slopes can allow rapid runoff of rain to the collector. However, the rate of runoff has to be controlled to minimize soil erosion from the catchment field. Use of plastic shields, asphalt or tiles along with slope can further increase efficiency by reducing both evaporative losses and soil erosion. The use of flat sheets of galvanized iron with timber frames to prevent corrosion was recommended and constructed in state of Victoria, Australia about 65 years ago. Now, soil compaction by physical means. This involves smoothing and compacting the soil surface using equipment such as graders and rollers. To increase the surface runoff and minimize soil erosion rates, conservation bench terraces are constructed along a slope perpendicular to runoff flow. Soil compaction by chemical treatments. In addition to clearing, shaping and compacting a catchment area, chemical applications with such soil treatments as sodium can significantly reduce the soil permeability. Collection devices. Storage tanks. Storage tanks for collecting rainwater harvested using guttering may be either above or below the ground. Precautions required in the use of storage tanks include provisions of an adequate enclosure to minimize contamination from human, animal or other environmental contaminants, and a tight cover to prevent algal growth and breeding of mosquitoes. Open containers are not recommended for collecting water for drinking purposes. Various types of rainwater storage facilities can be found in practice. Among them are the cylindrical ferrocement tanks and mortar jars. Rainwater containers. As an alternative to storage tanks, battery tanks, that is interconnected tanks made of pottery, ferrocement or polyethylene may be suitable. The polyethylene tanks are compact but have a large storage capacity, that is 1000 to 2000 liters, and are easy to clean. They also have many openings which can be fitted with fittings for connecting pipes. Conveyance systems. Conveyance systems are required to transfer the rainwater collected on the rooftops to the storage tanks. This is usually accomplished by making connections to one or more downpipes connected to rooftop gutters. When selected a conveyance system, consideration should be given to fact that when it first starts to rain, dirt and debris from the rooftop and gutters will be washed into the downpipe. Thus, the relatively clean water will only be available some time later in the storm. There are several possible choices to selectively collect clean water for storage tanks. The most common is the downpipe flap. With this flap, it is possible to direct the first flash of water flow through the downpipe, while the later rainfall is diverted to a storage tank. Now, advantages of rainwater harvesting. Relatively cheap materials can be used for construction of containers and collecting surfaces. Secondly, low maintenance cost and requirements. Collected rainwater can be consumed without treatment if a clean collecting surface have been used. provides a supply of safe water close to homes, schools or clinics, encourages increased consumption, reduces time women and children spend collecting water, reduces back strain or injuries from carrying heavy water containers. Now, the disadvantages of rainwater harvesting. Supplies can be contaminated by bird and mill dropping on catchment surfaces and guttering structures unless they are cleaned, flushed before use. Secondly, poorly constructed water jars containers can suffer from algal growth and invasion by insects, lizards and rodents. They can act as a breeding ground for disease vectors if they are not properly maintained. Now, watershed management. The watershed is defined as the land area from which water drains under gravity to a common drainage channel. Thus, watershed is a delineated area with a well-defined topographic boundary and one water outlet. The watershed can range from few square kilometers to 1,000 square kilometers in size. In a watershed, the hydrological conditions are such that water becomes concentrated with a particular location like river or a reservoir by which the watershed is drained. The watershed comprises complex interaction of soil, vegetation, landform, land use activities and water. People and animals are integral part of watershed, having mutual impacts on each other. A watershed affects us, it is directly involved in sustained food production. Water supply for irrigation, power generation, transportation as well as for influencing sedimentation and erosion, vegetation growth, floods and droughts. Thus, management of watershed, treating them as a basic functional unit is extremely important. The first such integrated watershed management was adopted in 1949 by Damodar Valley Corporations. Rational utilization of land and water resources for optimum production causing minimum damage to natural resources is known as watershed management. It involves management of land, water, energy and greenery, integrating all the relevant approaches appropriate to socio-economic background for a pragmatic development of a watershed. The objectives of watershed management are as follows. To rehabilitate the watershed through proper land use, adopting conservation strategies for minimizing soil erosion and moisture retention so as to ensure good productivity of land for farmers. To manage the watershed for beneficial developmental activities like domestic water supply, irrigation, hydropower generation, etc. To minimize the risk of floods, droughts and landslides. To develop rural areas in region with clear plans for improving the economy of the region. Now, advantages of watershed approach. It's environmentally friendly, saves time and money and involves greater people participation. Watershed management practices. In watershed management, the aspects of development are considered with regard to availability of resources. The practice of conservation and development of land and water are taken up with respect to their suitability for people's benefit as well as sustainability. Various measures taken up for management include the following. Firstly, water harvesting. Proper storage of water is done with provision for use in dry season in low rainfall areas. It also helps in moderation of floods. Afforestation and agroforestry. In watershed development, afforestation and crop plantation play a very important role. They help in prevention of soil erosion and retention of moisture. In high rainfall areas, woody trees are grown in between crops to substantially reduce the runoff and loss of fertile soil. For example, Dalbergia sisso, Tectona grandis and Acacia nilotica are grown in these agroforestry programs. Mechanical measures for reducing soil erosion and runoff losses. Several mechanical measures like terracing, bunding, bench terracing, no-till farming, contour cropping, strip cropping, etc. are used to minimize runoff and soil erosion, particularly on slopes of watershed. Scientific mining and quarrying. Due to improper mining, the hills lose stability and get disturbed, resulting in landslides, rapid erosion, etc. Contour trenching at interval of 1 meter on overburden dump, planting some soil binding plants like Ipomea and Vitex, and draining of water courses in the mined area are recommended for minimizing the destructive effects of mining in watershed areas. Public participation. People's involvement, including the farmers and tribals, is the key to the success of any watershed management program, particularly the soil and water conservation. People cooperation as well as participation have to be ensured for the same. The communities are to be motivated for promoting a freshly planted area and maintaining a water harvesting structure. Successful watershed management has been done at CEC-UGC, Panchkula, Haryana through active participation of local people. Watershed management in Himalayan region is of vital importance since most of the watersheds of our country lie here. Lastly, I would like to conclude by saying that in spite of the astonishing achievements in the field of science and technology, nature remains to be a mystery for human beings. Though water is also being obtained through desalination, artificial rain, by cloud seeding, etc., in some of the developed countries, the shortage of water, even for drinking purpose, is a perpetual phenomenon through the world, especially in developing and underdeveloped countries. Water has become a highly precious resource. Therefore, strategy of water harvesting and conservation is becoming popular day by day. Here I come to the conclusion of this lecture. Thank you.